Hello everyone. Today we are learning about graph in data structures, and this is a very basic introductory video for the graph. And after that, you can uh, solve any question of the lead code. And if you are not but you can go to the questions of uh, data structure on the graph. Okay, let me give you the very first definition of what is graph. Okay, graph in yes. Okay, let me give you very simple understanding what is the graph. Graph is a collection of two things. First is node, and there is another thing like the edge. Okay, we can draw it like a straight. Let me remove this and let me give like this. Let's suppose this is vertex vertices. There are many nodes because there are many nodes possible, and a connection between them. Connection, or we can say it by edge. Okay, and this is the collection of vertices connected through edges is called graph. Okay, and vertex we also said a node. Okay, let's suppose there are uh, two city. Okay, uh, one is Indore and second is Mumbai. Okay. Okay, there are two city, and there is a road between Indore to Mumbai which is connecting the this two city. Okay, here the cities are this city Indore is a node or vertex, and the Mumbai city is also node, and the connection, the road or connection or edge between them, road are the edge, which also we can say the connection between them. Okay, this is a real life example of a graph. Okay, let me give you the example where the graph data structure is used. Like I have already given the example you the like how the Facebook pupils for how the Facebook pupils friendship work. Like Facebook profile, your profile is work as a node, and the relationship between them, like you are you if you have the friend, you made a node between you and your friend. Okay, let's suppose there is two profile, like profile for you and for your friend, and you send request to your friend. You made a connection between you and your friend, and this can be a graph. Okay, now like in the Google Map, like in the Google Map, I have already given you the example that how the Indore and Mumbai connected, and if the Indore and Mumbai are connected, they give you the location, like the locations like Indore and Mumbai and the road which are connecting is the edges. Okay, this is the very introductory video, and I have explained you the definition of graph. Like next, what we need is the types of graphs. Okay, now like very first is undirected graph. Okay, and like in case of city, like let me take this example. Okay, and okay, the road between Indore to Mumbai. You can go Indore to Mumbai, and Mumbai to Indore by same road. By same road. You don't need to follow, like there is another road which is passing from Nagpur or Itarsi, and you are going to that road. You can go from that way, but you can also go by the same road where from Indore to Mumbai. Like you can go, like this is a road. You can go Indore to Mumbai and Mumbai to Indore by the same road. This is called undirected. Let's suppose this is like a hypothetical scene. Like uh, let's suppose let's suppose this is there is a way like Indore to Mumbai, but you cannot go Mumbai to Indore by that road. If you want to go Indore from Mumbai, you can go by another route. Okay, via passing another city may be possible. Like there may be possible, like there is another city here. Let's suppose there is Nagpur. Okay, there may be possibility. This is uh this is called directed route. You cannot go by the same route or the same edge. You can go to Indore to Mumbai by that route, but cannot go Mumbai to Indore with that. Okay. This is called this is called the directed route. You just have to listen, understand the thing. There may be let me explain you. There may be some terms like there are two nodes like A to B, A to B in the questions, like A to B, and you can go Indore to A to B, but cannot here what is mean? You can go A to B, but you cannot go B to A. There may be some another road or a way, but here if this is the complete graph, you cannot go B to A. You can only go A to B. That is its mean. If it is like if it is a undirected graph, then you can go A to B. What what undirected graph tells you? You can go A to B and B to A also by the same route. Okay. What directed graph says you? You can go A to B but cannot go B to A. This is the whole concept. Uh, Now there is one more type like weighted graph. Okay, you just have to understand. Like there is, let's suppose this is. Let me take this example again. Let me uh, make like when you go indoor to Mumbai, you have to give toll of let's suppose toll of 50. Okay, this is what? This is the cost of going indoor to Mumbai. Let's forget about the fuel. This is the thing you have to give when you go indoor to Mumbai. And if it is undirected draft, then you have to pay again 50 rupees, like when you go Mumbai to Indore. Okay. And similarly, let's suppose there is a directed draft. Here also can possible like 50 cost to Indore to Mumbai and 50 cost to uh, Mumbai to Nagpur and 50 again cost for Mumbai Nagpur to Indore. What it's mean? In the directed graph, there is the two things like undirected weighted graph. This is undirected weighted graph, and this is directed weighted graph. Okay, hope you are understanding. Oh, weighted graph. Okay, I like. Okay, if you want to go Indore to Mumbai, you have to give 50 rupees. But if you want to go Mumbai to Indore, you have to go from Nagpur. That's why you have to give toll of 50 and 50 again and again. Which means if you want to go Mumbai to Indore, you have to give toll of 100 rupees. This is the cost. This is the weight. Okay. This is what is the weighted graph. Okay. There is the another a basic thing must know like let me there is maybe okay, there is cyclic or acyclic. Okay, let's suppose there is uh, there is a graph which have node A, node B, node C, node D, node E. Okay, and there is a connection between A to B, another connection between B to C, another connection between C to D, and another connection between C to, let's suppose, okay, there is connection between B to D also. Is there any cycle? No, there is no cycle. Cycle means what? If you start with A, you you traverse all the node and come back to A also. Cycle is just like let's suppose there is another connection between D to C. Like you go A to B, B to C, C to E, then E to D, and again go to B. What it's mean? You again comes to B. What it mean? It mean there is a cycle present in the graph. If there is, we break a connection like this connection, there is no cycle. This is called the cycle and acyclic graph. Okay. Oh, this is an example of cyclic graph, and if there is a cycle like cycle between B to D, this is example of uh, actually this is example of cyclic graph, and this is example of acyclic graph. Okay, there is no cycle, that's why it's acyclic. There is a cycle, that's why it is cyclic. Okay, this is the very basic thing you need to know. And there are graph representation and DFS BFS also, and we will cover that in the next video. These two things is just you need to know before going to the any lead code problem. Now this video is about the graph representation. There are mainly two ways for representing a graph. First is adjacency, list, which is most used, and the second is adjacency matrix. Okay, let me break down it. First of all, what is adjacency list? Let me make it with a simple example. Let's suppose we have different, these are the different nodes. Let's suppose this is node A, this is node B, this is node C, this is node D, this is E, and this is F. Okay, now we are making connections. Let's suppose A is connected to B, and to E also, to A connected to B, A connected to E, and A is also connected to C, let's suppose. Now B is connected to D, and B is also connected to F also. Okay, how to represent it in adjacency list? First, let's suppose we made like here, how, let me give you like A, we have A, we have C, we have B, we have C, we have D, we have E, we have F. Okay, now how many are connected to A? First, A connect to B, and A connected to C, A connected to E also. Means A connected to B, A connected to C, and A also connected to E. Is there anything else? No. Now next, how many are B? How many connected to B? B connected to A, B connected to D, B connected to F. Okay. Now, how many connected to C? C is only connected to A. Okay. Now, how many are connected to D? D is only connected to B. Now, how many are connected to E? E is only connected to A. And how many are connected to F? There is only B which is connected to F. Okay. Here, like what we can understand, we have list for every node. Like we have no list for the A which is connected to B, C, E, and we have list which is connected to B, A, D, F, and we have C which is connected to A. We have list which is connected to D, which we have left. We have E, we have list for E and list for F. Means we can make it like there is a vector. There is a vector of list. Okay, try to understand. Try to understand. We have vector of list. Okay, or we can also make it like we have list for every node. Let's suppose I'm giving this, and for how many list we have, number of nodes, how many number, let's suppose we have n number. Okay, we have list means we have list for every number. Okay, for every node. What it's mean, we can define it like we have list for A. What can be it? B, C, and E. Okay, we will list for B. What it is? A, B, F. We have list for C, which is A. We have list for D, which is B. We have list for E, which is A. We have list for F, which is B. Okay, this is all. This is all. How many lists we have? How many list we have? We have list. How many number of node we have equal to the how many number of list we have. Okay, it is a collection of lists. That's why we made an array of data type of vector. Okay, okay. I think I explain it in very simple way. Uh, Let me give you the example of adjacency matrix. Now this is the example of adjacency matrix. Okay. Let's suppose uh, we have nodes, mini nodes like 1, 2, 3, 4. I am giving it numbers 1, 2, 3, 4, 5. Okay. Now 0 is connected to 1 and also connected to 5. 1 is connected to 4 and 4 is connected to 2, and also connected to 3. Okay. In the adjacency matrix, we have column and rows. It is a collection of column and rows. Let me take, we have we have column number 1, then column number 1, then column number 2, then column number 3, then column number 4, then column number 5. Okay. And similarly for, we have rows. Row number 1, 0. We have row number 1, then 2, then 3, then 4, then 5. Okay. For we check, like, if 0 are 0 is 0, 0 and 0 connected to each other, we say no, it's not connected. We tell like 0 and 1 are connected, I say yes, it is connected. And we check 0 and 2 are disconnected. Are this connected? No, this is not connected. Is 0 and 3 are connected? No, it's also not connected. 0 and 4 are connected? No, it's also not connected. 0 and 5 are connected? Yes, it is connected. Now we check 1 for 0. Yes, it is connected. Then we check 1 and 1. Is it connected? No, this is not connected. We check 1 and 2. No, it's not connected. 1 and 3. No, it's not connected. 1 and 4. Yes, it is connected. And 1 and 5. No, it is not connected. Similarly, we will make for 2 and 0 is connected. No, 0, 2 is only connected to 4. So we will only put 1 on the 4. Okay. Okay. Now, how many are there which is connected to 3? There is only 4. How many connected to 4? 1, 2, and 3 are connected to 4. 1, 2, and 3, na? That's okay. How many connected to 5? There is only 1, 0 which is connected to 5. Otherwise, all are not connected. Okay. This is the adjacency matrix. We build it using the matrix, like 2D array, using 2D array. Okay. Now we understand basic theoretical understanding of how the BFS is work. Let's suppose I have a graph, like, which is first 0, then there is 1, then okay. Let's suppose this is our graph and we want to traverse it. Breadth first search. Okay. First of all, what is breadth first search? Breadth first search is something like, if we start from, let's suppose we start from 0. We print 0 first, and every node which is connected to 0. How many are which is connected to 0? There is, let me give, this is 1, this is 2, this is let's suppose it's 4, it's 3, it's 5, it's 6. Okay. And how many are connected to the, first of all, the root node? Then how many connected to that rod? that node which is 1, 2, and 4. Okay, then it can be in any order. It can be in any order. It can be 1, comma 2, comma 3, 2, comma 4. Okay, but it can be 1, 4, comma 2. Okay, there is no preference. But after this, it will take any node. Let's suppose if there may be possible one also have one also may have the one more node. Okay, let's suppose it has 7. Okay, now this is let me make this is level 1. This is level 1. Okay, and what is and this is like 1, 2, and 4 comes in level 2. It should after the root node. And what is in the third level? Third level covers 7, 5, and 3. Okay, what cover it? 7, 5, and 3. Okay, it's mean after this 7 come, 7 can come, 5 can come, and 3. The very last, the 6, because 6 is the way largest distance from the root node. It have on the third level, and 6 comes in the fourth level. Okay, means first of all the root node and everything which is connected to the root node comes on the second place, and after that the that root node next means connected to the that nodes will come later, and after the last node after that which is connected to that. Okay, this is the BFS. Okay, now we understand DFS. Okay, let me like let me remove this. Okay, okay, let's suppose we have same graph, and we started from 0 as a root node. 0 is our root node. What we do, what we do is we first write this is our DFS traversal. Okay, which traversal? This is our DFS traversal. First we write 0, then we write the root node. Okay, then we select any one node connected to 0. We can take 2. Okay, we can take 2, we can take 4, we can take 1. Let me take 1. Then it's mean after the 0 1 will appear. Then we take the node which is connected to 1. We will not traverse 2 and 4 first. We will traverse the deeper. Then we backtrack and traverse the other node. What is connected to 1? There is 7. Okay, there is no not other node which is connected to that node. So we backtrack and backtrack again and go to the 0. Go to the 0, and we will go to the node which is 2. Okay, then we print 2. There is no node connected to 2 other than parent. So we backtrack to the root node and then go to the next node which is 4. Okay, we go to the 4. Then we go to the node which is connected to 4. We can either go for 5, we can either go for 3. Let's suppose we go for 3. Okay. Is there any other node? Is there, sorry, if we traverse to 3, we check, is there any other node? Is there any node which is connected to 3? Yes, there is a node which is 6. Okay. Next, there is no other node then which is connected to 6. So we backtrack and go to the 3, then backtrack, go to the 4, and then traverse to 5. Okay. This is our DFS traverse. Okay. This is the simple definition like thing which we should know before going to understand that and understand the graph and doing the lead code question or any platform question. Okay, today this video I will explain the concept of tree in data structure. A tree is a hierarchical non-linear data structure consists of nodes connected by edges. One special node is the root, and from it all other nodes branch out. Think of think like a family tree or a computer folder structure or HTML document. Like this is a root node, and you can create more like this, and this. Okay, here you can like make like this is connected to this, and 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 this is connected to this. This can be a tree. Okay, and here the root node. This can be a root node. This can be a root node. Just we have to define this is a special node which is root. Okay. In our case, we take this to be a root node. Okay. What is node in it? Every circle is a node. Okay. Like there is, let's suppose A, there is B, there is C, there is T, there is E, there is what it's mean. A connected to B and A also connected to C. B connected to D, C connected to E, and C also connected to F, and C is also connected to A. Okay, but it is little different. Like C is connected to A is little different, but yes, it is connected. Okay, here like let's suppose this is one level. This can be a level. This is another level, and this is another level. We define level on the basis of root node. Okay, what is mean to be level? Level is like if it is a root node, if it is like it is level 0, let's suppose it is level 0, how many are connected to that root? B and C, direct connection. Okay, the direct connection means it is on level 1, and A is connected to F. In between, there is one node also. Like A is connected to something, then it is connected to F. Means F is on level 2. Okay. This is the depth actually. This is actually the depth. Okay. Oh, now, like, what is height? Height, the number of edges on the longest path from the node O to the leaf. Okay. Means what is the height of this tree? The height of this tree is like 1, 2. Okay. This is considered as 0. Okay. Leaf, why we are considering it is a 0? Because it is goes from the leaf node. Okay. The leaf node is something which is not connected to anything. This is called the leaf node. Okay. I will explain you later. If some have some queries you have, um, and it is on its height is 0, its height is 1, its height is 2. So what is the height of this tree? Height of this tree is 2. Okay. Now what is subtree? Subtree is like this. This is the subtree of this tree. Okay. Subtree. Some basic definitions like now the type of tree. What is the type of tree? This we have understand the general tree, which is made up of like node and the connected part, edge, we can say, but it is little different from edge. Now, what is binary tree? Binary tree is something like each node has almost at most two child. In here, there can be possibility like B can have the three child. There can be possibility he may have some more child, but in the binary tree, there only two childs. Okay, there is only two child always. Okay, this this is something which we can as a binary tree. Okay, okay. Now, like the basic definition of binary tree: a binary tree with ordering left child. Here, like let's suppose uh, this is 50. Okay, then the left part is always smaller than the root node. Okay, then it can be 45. Okay, then its left part will be smaller than 45. It can be 40. Now, if it is 45, the right part is always greater than 45, but it is smaller than the 50. Why it is smaller? Because it is coming on the left. Okay, don't be confused by this. This is pointing to something else. Okay, means it can be between 45 to 50. It can be 47. Okay, now here in the right, it is always greater than 50. It can be 80. And if there is like one more element, it will be smaller than 80 but greater than 50. It can be 70. Okay. Now similarly for the here it can be 90. Okay. And the last can be uh, null, and this is pointing to null, this is pointing to null, and there two child is also pointing to null. Okay. I will explain in better way when I am implementing the tree. Now, I'm sorry, this is the example of binary search. Okay. And where the only two child, okay, where the only two child, there is not like child is smaller than parent, like what I have before. The things like I have explained, like 50 is smaller and 45 is smaller. This is binary search tree, you understand? Let me explain the binary tree again. Okay. Binary tree is nothing like it is all the node can only have two child, two or one child. Okay. This is example of binary tree. Okay. This is just a binary tree. And if we have the relation like always left node is smaller and right node is greater, then it will be binary search tree. Okay. These are some basic example of tree. Now there are many more trees like avial tree, red black tree, and heap, and try, and heap is like let me explain you heap. Mm, heap is something like it is part of binary tree where a complete binary tree where every parent is smaller or larger than its child. What it's mean? Like if I have like this, let me make it factory. Let's suppose this is the heap. How can we make it like heap? Can make it like okay. How can we make? There can be two type of heap, mean heap or max heap. If it is mean heap, then the always the root node is always the smallest. Small will be the almost always the smallest. Let's suppose 0. If we remove the 0, automatically the next smallest will come into the root node, which can be 4. Okay. If it is max heap, the root node is always contain the maximum or largest. Okay. Then is its child. Okay. I think I have explained in very simple example. And there is one more which is try, which is efficient for string search. I will explain it in better way in next videos. Let me explain you the binary tree in detail. Okay, we have already understand that what is tree, and I will explain you in a better way And first, I am explaining the binary tree. Like, what is the binary tree? Binary tree which contain data and two pointer. Okay, like there is a there there is a node. This is the node, and here what will be in this node? First we have a value and a pointer which is pointing to left, and another pointer which is pointing to right. Okay, this is all we need in binary tree. Let me let me implement. Like, it can be like, if the value is 50, it will point something like point, there's two pointer, there is left pointer, there is right pointer. Okay, and it can be, initially they will point to null. What? Initially they will point to null. Okay, I will explain you by implementing in the VS Code. Let me explain in VS Code. Like, let me remove open 24 slash binary tree dot cpp. Okay, here let me include the whole file, which is git slash std.h, using namespace std new man and return 0. Okay, we can make it in structure, like struct, and we made a node, and which hold a data and a pointer to the next node. Okay, which is left, and another is right. Okay, this is all we need in a node. Okay, and initial constructor which will take a value, and where is node data equal to value, and this dot left equal to null null ptr. Similarly for the right. Okay, and this is, we made the node for the binary tree. Okay, it's a very simple way I can explain, and I think you understand it. If there is no problem, let me try to make node star root, and dynamically it a node where I will make first root node to value is 1, and let me try to see out root data. Now let me try. It should work and give me 1. Okay, it's working. Okay, now I think I explained like here we have node, like when we initialize the root node, the initially the value which I am giving here is stored in data, and the left and right pointer assigned to null pointer. Simple. Okay. It something look like we can understand it like this. Okay. Now what is next? Okay, it's recording. We can do like this also. Root left, and we can assign the left node like new node star, which is 2. Okay, and similarly for the right, we will give it 3. And here I will write like root left data, and similarly for root right data. Okay, let me see out also root left of left, and it should show me the null pointer. Okay, let me make see out del, and it should, it is giving 0 in the last because it is the null pointer which is left of left. Okay, now I think I have you understand what is the root, like what is the binary and how it is work with C++. And next I will explain you binary search tree.